Welcome to the lecture series on object-oriented analysis and design. As we progressed in this series of lectures, we have been understanding that we need to solve more complex real-world problems. That means we welcome complexity, which roughly translates into huge code sizes. The life cycle process becomes that bit more challenging. The life cycle definition, the choice of life cycle, many ideas have come. We have talked about systems, but then what remains stable across a very good range of applications is object oriented as a technology, the software engineering idea based on technology, and it has matured over the last 20 years, 25 years into what is called a unified modeling language. However, the object oriented revolution has left many companies wondering what went wrong. Very exciting idea. People were really seeing, instead of saying that I am seeing 100 birds, how is it occurring in your program? Integer bird. It takes so many values. Normally it takes from minus infinity to plus infinity, but then you have to see a bird in that integer. What is the first and the best and the only clue? The name of the variable. So when we were talking about the pre-object oriented days of programming, our best way of relating to what we were doing in the program, what we were representing in the program, is the naming convention. We have created a very good Hungarian naming convention, and then it works up to a point. Gradually we know that it should be an object called bird, because bird as a number, bird as what that bird is eating are not the same. That bird eats certain things. Depending on the species of the bird and all that, it eats something else. So what we have done therefore is that this dichotomy of bird as a representation, bird as what it does becoming different, dichotomies they are different, has caused many coding horrors. So we found that object as a bird, it tells everything. A class of birds, 100 birds create 100 objects of that class. Class of eagles, class of parrots, you just put that. The birds are like that. 100 objects are created, each object is known to do this. We know what is the behavior necessary. Makes sense. It makes a lot of sense, provided we can identify objects so clearly and model them. It appears that we have been doing a good job, but then very soon we realize that we won't know where exactly things have gone wrong also in this method. The efforts of their best developers have not lived up to the promise of tool suppliers and application gurus. Many of these organizations have not yet realized that their developers' grasp and application of OO methodologies as critical as their prowess with OO tools. So naturally, in the field of software development, whenever we ran into these conditions, similar conditions, we have been looking for a tool support, because development organizations don't have time, don't have money to do so much of learning or recognizing at some point we went wrong. We simply said that whenever we faced this kind of a situation, any discipline, we wanted a tool. If so many people are having similar difficulties, better bring one tool into the picture. This is true for ages. A tool and its origin is a very good study. There are plenty of books, plenty of literature on how this tool has emerged. Many of these organizations have not yet realized that the developer's grasp, it doesn't mean that it's a panacea. The tool is not going to do anything. The tool is a tool. It is there. What you want to do with that tool, if people are clear, then it will be fine. So what we said was, for using the tool, for mastering the tool, power users of the tool, everything still stands. As a tool, it is like this. How you can leverage it to benefit to you is up to you. The challenge for tool suppliers is to create a strong link between their OO modeling, analysis and design tools and the source code itself. The desired characteristics of the object-oriented tools: support of common methodologies, a way to check the model for consistency, support for various sized teams, easy integration into the development environment currently used. We have had these difficulties earlier on. When we were talking about programming, we said the compiler will take care. If there are any compile time errors, because it is written well based on the grammar, the context free grammar that makes the definition of that language happen. When we started banking on the compiler, it tells these are the compile time errors, syntax errors, you can correct them. How do I write this program? What is the editor? Well, that's a separate piece of code called an editor, a line editor, a screen editor, or later on when we were talking about with a very good user interface, we get a much more advanced editor. So which one do you want to use? Now these are all archaic terms. We are talking about a very good editor. It is no more separate. It is along with everything. One button is compile, one button is edit, one button is run. There are so many other things, multicolored boxes. You can talk about how many times this variable name was used, where it was used. It will tell precisely where it is used. It will find out so many things. A very good integrated development environment has happened with the design of the very well known language called Smalltalk, which is object oriented. The very first good integrated development environment happened with this language called Smalltalk. As you put together the objects, you will see how they are combining. The ability to generate code from models, that's exactly what UML has perfected. Once you are clearing the O, AD and the UML, press the button. After choosing the language, the code will come in that language. Since the automatic code generator is very robust, we don't spend much time on testing. Even if it generates more lines of code, which may not be optimal code, it doesn't matter. We have saved so much time coding. Now the machines are faster, the memory is just there. Yesterday I was listening to a lecture, they were talking about 64-bit registers not being enough. They are doing a wonderful application, a great matrix has been created, that matrix has to be used. Each time they were optimizing on the available 64-bit registers. If that's true at some level of application, even now we are doing that exercise. Even now we want to optimize, but by and large, we know that we can invest now on much better computing platforms which are faster, which are not so stingy on the memory. Memory is just there for you to use, gigabytes, megabytes, everything. So in the next model of my mobile is expected to show a phenomenal increase in the kind of memory it has. Support for building reusable components. It happened very quickly when I purchased the mobile. That memory was reasonably large. People never expected that WhatsApp will become so famous. People didn't expect so many other applications becoming so famous. Past 2 to 2.5 years, WhatsApp has become something which is so dominant, and each time content comes, it eats away the memory. WhatsApp occupies maximum memory and we subscribe to so many lists, it happens. The next mobile model is likely to be much better. One of the USPs, unique selling points, is going to be a huge memory. A price tag for buying, installing and training that is within budget. The tool functionality, it should capture the business model. Who should approve the tool? Not necessarily the developers, but the people who are stakeholders. The business should tell that yes, it is in conformance with what I want to do. Tie the business model to implement software features, support for standard methodologies, model consistency checking, multiple developer support for modeling, integration into integrated development environment. The idea about standards is well known, but standards don't happen in a vacuum. It should be well supported. Any standardization effort has been like that. There are two ways of doing that. One is a de jure standard, that is we form committees of experts, teams from various viewpoints looking at this over a long spell of time and saying that yes, after so many deliberations, we want this to be a standardized methodology. It doesn't mean it's sanctum sanct. But then it is like that, standards, revision, everything is like that. Everything we are talking about is going to be looked at. The next idea is de facto standard. We started working with something, there was a huge business concern, it has creating a demand that made it an everyday exercise. Since so many people are using it, it must be a standard, all people are happy about it. So what we have been talking about in all these exercises is the fact that we have come thus far, de jure or de facto. We talked about data standards, so many things. Suddenly we got this idea called provenance. Data has to fit into a cultural and social context, otherwise why is it called data? Otherwise why will that culture accept, why will that community progress? It has to thrive as a community. So we started talking about so many things. We now have a standards exercise. Very soon we are having some meetings. Provenance is something which is very necessary. Model consistency checking, multiple developer support. So all these things are evolving, so you can easily expect that there may not be a single tool that does everything, or there may not be a single tool that will withstand the spell of time that we are talking about. There may be multiple versions. Many things are true, but out of all this, one particular tool called Rational Rose has shown us a kind of a promise over a long spell of time. Investment in training paid off, purchasing that tool paid off. No other tool in this area had that kind of a longevity. No other tool that in this area had the way of sustaining for so many years and across such a vast functionality which we are talking about. Integration into an integrated development environment, Smalltalk, Visual C++, it does not matter to me what is that integrated development environment, this tool should simply fit in. I will simply select Smalltalk and go away, it should fit into the Smalltalk development environment and proceed generating the code, testing and giving it to us. Visual C++, Symantec, Borland, etc. Code generation, reverse engineering, component repository with version control, development at the diagram or code level. So we need to understand that a good tool will tell that this is the diagram, what do you want to do with this? Do you want to generate code, or do you want to simply go ahead and see, project what happens if this diagram is linked to another diagram? If it is code level, what happens if this code is linked to another code level? Component repository, aggregations, like we said, integrated chip objectory was one good idea. Component repository, component factory, we keep on talking about such ideas with version control. Components can have multiple versions, tools can have multiple versions. Reverse engineering is an exercise where something is done, you are watching how it is done and trying to understand what is it to be done. We do not know the internals of how it is working, but if you watch so many times, you will get a feel for how to do it yourself, and if you know how to do it yourself, you can convert it into a code and make it run on the machine. Keep using the tool several times, very likely that the dominant functionalities and features can be redone without consulting who made the tool, why the tool is made like that. It depends on your skill, your caliber to make it efficient, make it cost effective, but in reality, yes, if you keep watching some popular tool, use it n number of times, you are likely to get a feel for what it is doing and why it is successful. You can replicate that. You can replicate that, write your own tool. Code generation I have already spoken about. So this is what we have been expecting out of tools. And what are these tools called? They are called computer aided software engineering tools. They are called CASE tools. So the CASE tools has become a wonderful support in the entire arena of software development. UML, no UML, or what you want to do, whatever you want to do in software engineering, computer aided tool will happen, because plenty occasions, plenty of contexts were there when we were hitting the wall or falling into a pit and we didn't know how to come out of it. So what we did is we started looking for tool support. People have made tools, Many organizations have constructed tools for themselves. We can talk about such things. There was a point in time when I was using my own facilities in the department, and it was generating a document in one format. I have to come across to another facility, same university, to send the email, and that email client does not read this format. It's difficult for us. We had a cumbersome way of changing the format until we came across a tool that tells that you give this as an input, it will give the converted code as an output. We know what we were doing before the tool was there. We had to get some help, go to some place, do it there and come back. So we have been talking about such tools. Well, in theory, we are punctuating this discussion with software tools, but then we can always have tools like devices which are always there to take care of certain things. During the days of punched cards, we had a card puncher. It's a very special device. The card puncher can be anywhere. It's a simple handheld device. They keep on punching at an amazing speed. We even today we talk about abacus. The people who are experts in this abacus, they do it at a mind-boggling speed. The beads will fly on that abacus. It works like that. The way in which we are talking about tools and tool support in this lecture session is punctuated with software tools. The scale and complexity of many systems we are currently attempting to build is severely stretching the capacity of existing software development methods and notations. It is not that we are not able to cope up with this scale and complexity, it is just that our methods and notations which are existing so far are severely challenged. We didn't anticipate that this kind of a requirement will happen on Software Fellows so sudden in a way. It was just there, it was happening. So that's a conjecture. The reason why we are worried about dealing with complexity is not only clarification of intent, but also preservation of intent is necessary. We should understand precisely what was the requirement from the stakeholders and carry forward right through to the implementation. These are two essential things. Dealing with complexity, we have concerns. Clarification of intent, preservation of intent. People are not so clear. People are not so clear as to what exactly is to be done. Most of the times, we start with the same statement saying that the stakeholders do not know what this computer can do for them. The stakeholders do not really know what they want to do also most of the times. But they definitely know that these are some frequently occurring concerns which they think are easily solvable provided there is something called a tool, something called an automation. So can we do that is the question. What is desperately needed are design methods that can amplify our ability to deal with the complexity. So complexity cannot close our eyes, complexity cannot be misleading, daunting, scary. It is just that we need a method to go about dealing with the complexity. So we strongly think that the pivot is the design, not proliferating number of lines of codes. It is not that at regular intervals we produce 10 million lines of codes. No, the design, that is where the fulcrum is, that is where the crux is. The stumbling block with complexity is the limitations of human short-term memory. What's the concern here? The concern is not that we talk about a volume of requirements. We are always concerned about the question, are you connecting the requirements that are impacted by a small change or a big change or whatever change? Human short-term memory implies that at any given point in time, I can track 7 things. Any 7 things. I can track any 7 things. Beyond 7 things, we have a sliding window. I lose sight of one thing. In the web world, there have been some serious studies saying that it can be 9. In theory, we keep telling in all these exercises, plus or minus 7 plus or minus 2. That's the way we talk. That's a confidence interval. Normally, by default, we should be able to track 5. and at a stretch we can track up to 9 things. So what we have been talking about is a number 7 that tells that by and large, on an average, most people are capable of tracking any 7 things simultaneously. They are all there. So a change in one, they are very quickly visualizing what happens on the other 6. Very quickly, it does not require a supercomputer, it does not require a great training. By and large, human beings are capable of doing it. What happens if it overshoots the double figures, 10? What happens? Then we are not confident. We can track the connections, but then we are not taking care of all connections. What's the typical size of requirements that we are looking at? An old Boeing model had 18 volumes of 400 pages each as requirements. 18 volumes of 400, that's nearly 72,000 pages. It's something which is a very daunting number, 7,200 number of pages, 7,200 pages. So very likely that a small change in the requirements is throwing up something like 20 changes. Where are the changes? How is the document written? Now the goal shifts. What is our goal? Our goal is to develop software. Now we are rolling into the documentation. There is no end to it because changes happen. Every time the change comes, we have to redo the exercise. So that's how it is. Conjecture, we need design methods that acknowledge and accommodate the limitations of the human short-term memory. That's the purpose of computing. We know for sure that there is drudgery in many things that we are doing today. The provision of a computer is to take away the drudgery from the human being so that the human being concentrates on becoming more and more creative, tackles more and more complexity, and therefore the machine becomes more and more useful and therefore popular. So what we are talking about are the greatest challenges: complexity, how to go from requirements to design, detecting requirement defects very early, accommodating change, how to get a set of requirements. Nothing is cast in stone. There is nothing called a frozen requirement, but complexity is like this: how to build large software systems that exhibit complex behavior and which must satisfy large numbers of functional requirements. The requirements of a large system might run into hundreds of pages. The real problem is the mass of detailed requirements, said Hoare. Typical requirement is like that: if I change MG3, what is the guarantee that MG2 is not impacted? If I change MG 2.2, what is the guarantee that MG 8.8 is not impacted? It's a case of some satellites, a simple example, old satellite requirements. It's an old document that I am having. It is like that, and what is it that we can do to ensure that all impacted requirements are automatically collected? Oh, it all depends on the structure of the document. If I touch MG 2.3, I should somehow make this document proactive and tell me that MG 2.3 is connected to so many other requirements. Therefore, if you are changing MG 2.3, these other 15 requirements, you should find out whether there is a change that is necessary or not. Well, it becomes very difficult, very cumbersome because change impact analysis is a bigger exercise which we are not really going to do. If you can write such crystal clear document for requirements, then you would not have thought of alternative paradigms. If you can come up with frozen requirements, there is nothing like it. The problem with complexity, what makes something complex is not so much the number of details, but rather the number of details we need to be aware at any one point in time. That's what is the concern. Some hope with complexity, people don't mind dealing with complexity if they have some way of controlling or handling it. We need an assurance because we are responsible people. Something is going out of my hand. We know that it's out of my hand. We talk to some people. I don't have the expertise on the camera, but if I can just get a feeling for something is not making me feel all right with the camera, I have a good expert on the camera who tells me that if I do this, it works, then please go ahead, you forget it. If a person is allowed to structure a complex situation according to his perceptual and conceptual needs, sheer complexity is no bar to effective performance. It is complex for me because I do not have that acumen, I do not have that expertise to deal with camera, and it is a huge instrument into which I am staring. So, if I can have a structured way of assurance that yes, this is how it is solved, just do not bother, I will not bother. Then I will build further, next comes the light, next comes that is how I build more complex exercises for myself. Sheer complexity is no bar for effective performance. These are all very well known pioneers. From functional requirements to software design, there is a huge gap. Not many can cross this gap. Most of the times the pitfalls are all here. Most of the times the pitfalls are all here. And that is where we are really concerned about, and we do not know how to cross the chasm unless we do all these exercise of paradigm, object oriented, tool and everything. Scan all the use cases looking for the high risk items. Use case tells me very quickly which is a high risk. That is the best use of use case which Ivar Jacobson has taught us in terms of object oriented software engineering. It is an award winning idea. Scan all the use cases looking for high risk items, key functions that are likely to have a strong effect on the design. The team then creates a design to fit these key functions, hoping that remaining functions will not disturb the design. So, the use case is so nicely structured, automatically you know where to give your priority. We see the good functionality happening based on use case. One of the lectures that is going to happen is use case driven. It is worth it. As I mentioned in the earlier lecture, we began with test driven development, model based development, user centered or user driven, and then we talked about use case driven. It is necessary to understand that object oriented is perhaps the only technology that has given us a way of working with use cases in terms of prioritizing the functionality and going ahead with it simultaneously. No other technology was giving us this idea, something unique. Writing effective use cases is a very good idea. It's not so easy, but we have to do that. 65 to 85% problems can be traced back to requirements. That is what we have been talking about all along. Requirements change is in the problem domain. This makes the change in the solution domain difficult. We can change the problem easily, but the solution cannot change very easily. Imagine you are writing an examination, the question paper is there, the question is there, suddenly there is an announcement saying that question number 14, there is a small change, instead of 2 you make it 3. The number 2 is made to number 3, how difficult it is. We want to minimize such announcements. Lot of care goes into making the question paper. We have a way of working. Now, in all these cases, people are the simplifiers. So, we keep telling in a teaching learning environment it is very easy. A good student is expected to cater to that change. It is a part of the examination, it can be easily be called part of the examination. So, we have been talking about a training methodology that tells that if you are having 3 hours laboratory exercise, 2 hours you solve the problem, start implementing it, next half an hour the problem is changed by 50%. What will you do? That is a challenge. That is a real life challenge. In examination, the cost of that change is not so high. In a laboratory exercise, the cost or criticality of that change is not so high, but that is expected. Change is the only thing that is constant. And how do we do that? So, in summary, we have looked at some nice things which we are confident about. If a tool can cater to all these things, I will be happy with the tool. That is the summary of this session so far. We are happy to invest on the tool, we are happy to learn the usage of the tool, because these are all the challenges, these are all the difficulties. If you can give a tool that can give me an assurance that it is complex, but it is assuring that all this is taken care, we will go ahead with that. Case tools, tools aid and limit our capabilities, tools change, tool dependency is dangerous. Thank you, we will meet again in the next session.